Hey folks, here's my submission for the Coursera PM course. Um, the assignment is to predict electrical energy output by building a model which will predict that of a combined cycle power plant. So here is my approach. Objective is to build a model that predicts energy output of a combined cycle power plant. The dataset provided has 5 attributes. Um, So this is the data attribute. So there are 4 attributes which are temperature, exhaust vacuum, ambient pressure, relative humidity. And the fifth one, power output, is what we are going to predict. From the data set, I think we have around 9,600 records or so that have been given to us in the CSV file. So we need to predict the power output and see how the model that we are going to build works suitable for this assignment. Since the dependent variable power output is a continuous one, I thought of using regression analysis to predict its value. And I'm considering all the 4 features provided in the dataset: temperature, exhaust vacuum, ambient pressure, relative humidity. Since it is a since it is a combined power cycle plant wherein there are multiple ways of producing electricity, based on my initial reading from Wikipedia and Google, let me know that these all 4 attributes or features kind of impacts the energy output from that combined power cycle plant. So I'm considering all these 4 features. Coming to building the model, I used regression analysis from the MS Excel tool, to be specific, linear regression. Um, okay, so as I mentioned, I made use of all the features from the dataset, the 4 attributes or columns that has been provided. I installed the data analysis pack from the Excel add-in and used the regression analysis. I selected power output, the dependent variable which we are going to predict as the target variable to be predicted, and the other 4 variables, the features that we have identified as features for the model for the regression analysis in Excel. So based on this regression output, we will come to know how each and every one of the features like temperature, exhaust vacuum, ambient pressure, relative humidity is going to impact either positively or negatively to the energy output or power output from the combined cycle power plant. So here is how my Excel regression output looks like. I will just quickly go through some of the key items. One is the R square value, which stands out around 92.8 percentage, which is kind of high. Uh, then we have this coefficients. We have the intercept, which is 454, and we can see that the temperature, exhaust vacuum, ambient pressure, and relative humidity kind of are all negative. Temperature being having the lowest value, which is -2 approximately. Um, so this is how the regression output looks like. Based on that, I created an equation using the coefficients from the regression output, and I used that to predict the energy output using this particular equation. So this is the data set. I have beautified it for the purpose of presentation. So these are the 4 features. This is the value that we are predicting. These are the actual output values provided in the data set. The predicted ones are in column F, which I calculated using the regression equation from the coefficients. So if you see, the deviation is not much, at least for the whatever records that I could see here. The second one is kind of accurate because it has predicted 444.37 and the predicted value is 444.077, which is pretty close. The other values, as you could see at a glance, it looks like it's kind of -5 or +5 range. Uh, but then we can dive deep into that in the model evaluation, for which I have used mean absolute error and root square mean error. root mean squared error. So mean absolute error, what I have done is I have basically in column G found the absolute difference between the actual power output and the predicted power output, and average of that stands out to be 3.6, which is megawatt, since this is a power plant and energy output. The squared error, again same, the absolute error I squared it, and the square root of that average column H is what is the root mean squared error, which is 4.55. Let's see what this means. Mean absolute error MAE actually says how much the predicted values deviate from the actual. So 3.6 megawatt is kind of good. It says that it is either plus or minus 3.6 megawatt from the actual values. So our predicted value is not that off, which is good. But RMSE tells us it's 4.5 megawatt. Coming to that, this is kind of higher than the MAE value, which means that larger errors or the outliers are penalized more. So putting that all together, the R square value explains a reasonable amount of variance in the data. Our model is quite good considering the R square value is 92.8% approximately. MAE and RMSE are within a tolerable range for a power plant that produces energy output. Interpretation from the coefficients, as we have mentioned earlier, the temperature has the largest negative coefficient, showing that as temperature increases, the energy output decreases. The other features like exhaust vacuum and relative humidity have positive contributions to an extent, but those have some negative coefficients. Finally, the limitations of the model. As I mentioned, I have used a simple linear regression analysis from the Excel data analysis pack. So the model may not be able to explain or provide for the complex interactions involved between the variables or the features and the dependent variable, which is the power output. So this is a simple model and we have kept it very simple. The non-linearities and other complex interactions may not be accounted for in this model. Thank you.